our Fundamentals of Functions review questions, and we're going to work on this question 8 here. I had to hunt down some graph paper. All right, so don't need graph paper for this necessarily. We just asked to sketch, not graph. And that instruction means we don't have to be super precise as long as we satisfy all these conditions. All right, so I'm going to draw a little axis here. And I'll draw it down here. All right, that's fine. And on this axis, I map my inputs, my x's, and this axis, I map my outputs, my f of x's. All right, so what do we know? Okay, we know a domain is going to be, well, x can't give an input of 3 or negative 3. But other than that, all the reals are in play. And this one says the range is can go upward of 4, x is less than, pardon me, y is less than 4 or equal to it. Okay, so 4 is a max value. But other than that, we're talking about the reals. Great. This is a little funny. It says f negative 1 of 3, or the inverse of f of, when it takes an input of 3, gives 0. F negative 1 of 3 gives 0. So what I can say there is that if I take that value 3 and I stick it into an f minus 1 function, it outputs 0. And I can also conclude that that can go into my f function, output the value 3. So I can think about that either way, but I think it helps to know that when my input, my x value of 0 goes into f, I get an output of 3, which is to say x 0, y is 3. And that's the point 0, 3. All right. What other piece of data do I have? I have that f, when I put negative 1 in as an input, I get the same output as when I put 1 in as an input. But it doesn't say what that has to be, it just has to say that they're equal. So I think we get a little bit of freedom here to play around. So what can we choose? Well, we got to make sure that whatever output that is. So I'm going to actually try to write that in words first. What this says, I'm going to say, therefore, the inputs of negative 1 and 1 give the same output. That's all that says. That's what the equals means. The output is going to be the same, but it doesn't say what they're going to be. And other than that, that's all the restrictions we have. So we can choose anything we want. So I'm going to say, when I put negative 1 into x, I'm going to say I get negative 2. Okay, so I'll say, and when I put 1 into x, I'll also get negative 2. And it doesn't actually matter that I chose negative 2. What matters is that they're the same. So I'm actually going to say that's negative 1, negative 2, and 1, negative 2. Okay, now what else do we have here? We have a range, as long as we're less than 4. So that means somehow we have to go up to 4, though. And we can't have values of 3 or negative 3. Well, that's it, though. Okay, so I can connect these dots however I want. So I think what I'm going to do, just to play around, is I'm going to draw a graph like this. But I can't go all the way down to negative infinity without going up to 4. So I think I'll go up to 4 right here. And I'll duck down. But I can't have an input of 3, so I'm going to put a little dot there. And I'll have it drop down like that. It's going to go down to negative infinity for forever. This side, I think I'll have it do something different. I think what I'll do is I'll have it, oh, you know what? I don't want to get it too confusing. So I think I'll just have it go down to negative infinity. All right, there we go. So I'm going to make a note here if you're just looking at the PDF. This is an example. Your graph may differ. In fact, it likely will. It would be super weird if your graph didn't differ. All right, let's move on to question 9. Okay, question 9, we're going to be doing some inverses of functions. It's good exercise. All right, so what do we got here? Let's get into this. 9a. We're going to find f negative 1 of x, so we're going to start by replacing that with a y. We get 3/5 of x, and we're going to add 2. We're going to switch around x and y, and so it means x is 3/5 of y, and we're going to add 2. We're going to get rid of the 3/5, which is being multiplied by y, and we're going to get rid of the 2. And we're going to start with the 2, so we'll take 2 away. That gives us an x minus 2 is 3/5 of y. Now I can divide by 5/3, or 3/5 rather. But what I can also do is I can just multiply by 5. And I get 5x take away 10 is 3y. And then I'm going to just divide by 3. And so that gives me y value of 5x take away 10 all over 3. Nice and easy, and I should rewrite that as f negative 1 of x is 5x take away 10 all over 3. Okay, moving on to question B. Okay, so, well, that's interesting. All right, so sorry, it's interesting. There's something cooking in this question that is sneaky. You know what? I think I might just skip what's sneaky about it for now, but I'm going to put an asterisk that there's something else going on here. And if you want to know what that is, it just has to do with the fact that this value has a restricted domain. And so therefore, when we make this inverse function, we'd actually have to restrict its domain. I mean, I'm not going to talk about that right now, but what I'm going to talk about is just how we would do this in a normal way, if that wasn't the case. And if you want to know what that is, you come ask me during Flex or after school on a Tuesday and Thursday someday, and we can talk about that, because it is kind of interesting. All right, so I switched x and y while I was talking. Now I'm going to start solving for y. So the first thing I can do is do the opposite of square rooting, which is squaring. That's technically kind of true and kind of not perfectly true. Squaring is actually the opposite of square rooting a positive and a negative version of a value. Sorry, squaring is, I should say. All right, and that's where we get that weird domain thing. I don't want to get into it right now. So I'm going to say I'll just add 9, and I get x squared plus 9 is 2y. I'll just divide by 2 and divide by 2. And so I find that g negative 1 of x is really the square of x plus 9, all divided by 2. Okay. Next, I've got the value 1/2 x squared plus 6. All right, so that's y is 1/2 x squared plus 6. Okay, so first thing, switch x and y, right? So that's easy. Y squared plus 6. And then I'll take away 6 from both sides. I get x take away 6 is the same thing as half of y squared. And then I'm going to multiply by 2, which is the same thing as divided by half. But I like multiplying by 2 more. So I get 2x take away 12, and that's equal to y squared. And then I got to square root both sides, or principal square root both sides. And then I find that y is the same thing as plus or minus the square root of 2x take away 12. So therefore, my h negative 1 of x is plus or minus the square root of 2x take away 12. All right. Last question, and it's going to take up a little bit more space, so I'm going to do it over here. All right, so 9D says I've got the function y of x is equal to x plus 2 over 2x plus 3. All right, so I'm going to rewrite that as a y And I'm going to replace these values. So I'm going to say that's x is equal to, oops, that's y plus 2 over 2y, take away 3. And I got to multiply both sides by 2y, take away 3. That gives me 2xy minus 3x. And that's going to be equal to y plus 2. I'll get all my y terms on one side and all my other terms on the other. I'm going to put all my y terms on the left. I like my y terms on the left. I'll also add that 3x to both sides while I'm at it. We'll do it all in one step. And so that says I get 2x, y, take away y, and that's equal to 2 plus 3x. Now, here's where we got to do something tricky. In order to make it any further, we actually have to factor a y out of this expression because we have two y's, and if we can't add them together, we need some other way of uniting that y-ness. And that's one of the reasons we learned a common factor. So we brought a common factor of y out to the front, and 2x minus 1 is on the inside. We can test that if we wanted by multiplying that y back in. We didn't change anything on the right-hand side while we were doing that. We haven't isolated y yet, but we can now because it's being multiplied by this big thing. So we can just divide by that big thing. And so then we say y is equal to 2 plus 3x over 2x minus 1. Or rather, y at negative 1 of x is equal to 2 plus 3x over 2x, take away 1. All right. Last question. We have a function. We have to graph its inverse. Now, I made the mistake on the other answer key of using black, and I feel like the value didn't really pop. I'm going to try green, because I feel like red doesn't scan super well. Or should I just use highlighter? I don't know. I'm going to try green, and we'll see how it goes. All right, so let's start with this one. So we have a value of negative 8 and 0. So we flip those. So I'm going to graph the point 0, negative 8. I'm going to label it 0, negative 8. And I don't know how well even green pops. Well, I'll still highlight it afterwards. Now, I want to pick some other values. So these are kind of funky values, but this is a point. That's the point negative 7, negative 3. So I'm going to graph the point negative 3, negative 7. I'll label that too. Negative 3, negative 7. All right. And what other points do I have? Well, it looks like I have the point negative 4, negative 3, negative 5. Negative 3, negative 5 should become negative 5, negative 3. So I get a point here. What other points do I have? I've got the point 0, negative 4, so I'll make that negative 4, 0. Oh, I've got the point 1, negative 3, so I'll make that negative 3, 1. And 2, 0, 2, 0. Wait, no. Yeah, 2, 0. So I should put the point 0, 2. You don't actually have to plot all the points. You just have to plot enough points where you feel like you can fill in the gaps. So actually, I'm going to skip that point. I'm just going to go straight to 4, 0, which means 0, 4. And I can intuit that really this value of 3, 0 must have been in between these two at 0, 3. Now, if you're not comfortable with that, you can plot as many as you can until you do feel comfortable. It takes a bit of practice. And here we get this inverse function. And in addition, I should probably plot the line y equals x, just to help me visualize whether I did reflect this in an accurate way. Why can't I line up this ruler correctly? It's been a long day, that's why. All right, so throw in that dashed line, help me catch my bearings, say, well, does this look like a reflection? It kind of does, yeah. But I think to really bring that home, I'm going to highlight the original function, which is f. And I will highlight the other function with another color. I called it f, but actually wasn't called f. It was just called the function. So the inverse function, I'm going to funk up this highlighter as well. All funky. There we go. Okay, and that's the inverse. And we can see that it does kind of look like a reflection, a mirror image of it, of the other. All right, that is it. Those are the solutions. Ask me if you have any questions. I want to remind you I stay late on Thursday night, so if you want to stay and ask about any of those questions, we can talk about that in really as much detail as you would like. Good luck studying.